Welcome viewers. In this video we will see the synchronization of alternator, that is parallel operation of alternator. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, synchronization or parallel operation of the alternator. First we will see what is meant by synchronization. Synchronization is the process of connecting two alternators in parallel without any interruption. So we need to connect the two alternators into the bus bar, that is called synchronization. It can also be defined as the process of connecting an alternator with a common bus bar. So there are n number of alternators available. We need to connect the alternator into the bus bar, common bus bar. That process is called the synchronization. The bus bar to which the alternators are connected for parallel operation is called an infinite bus bar. Where we are connecting the alternator, that bus bar is called infinite bus bar. What is infinite bus bar? An infinite bus bar is one which has constant frequency and constant voltage and remains unaffected by changes in condition of any one of the machine connected to it. So while connecting the number of alternators, there should be a frequency and voltages are constant. It should not be unaffected. The performance of the bus bar should be unaffected. That is called a infinite bus bar. So the synchronization is nothing but connecting more than one alternator into the bus bar without any interruption. Now we'll see what is the need for this synchronization. Why we are connecting more than one alternator into the bus bar. What is the necessary for that? So need for synchronization. The first one is local or regional power use may exceed the power of a single available alternator. So the alternator, we know that is a AC generated. It will give the supply to the any regional or local place. So the single alternator is not enough to meet the load. So that we need to connect the more number of alternator into the bus in order to meet the power requirement. That is the first need. Second one, when alternators are in parallel, one or more alternators can be shut down for the emergency maintenance without interruption of the power to the load. So when the 4 or 5 alternators are connected, if any one alternator we need to go for a maintenance, we can shut down that alternator. So the other alternators are connected to the bus bar. So that is the second need. So any alternator need any emergency, that can be shut down. Other alternator will meet the power. Third one, increased load can be supplied by adding the machine without disturbing the original installation. So when the load is increased, for example during the evening time, peak hours, the load will increase. So at the time we can add one more alternator in order to meet the load without disturbing any original installation. That is the need for this synchronization. The first one is power requirement. Based on the power requirement, single alternator is not enough. So we need to connect more alternators. If more alternators are connected, any one alternator is going for emergency maintenance, the other alternator will meet the power. So we can go for a emergency shutdown with any one of the alternator. And third one, increased load. Suddenly if any increased load is there, that can be managed by connecting the alternator. So this is the need for the synchronization. Next we will see what is the condition. What are the conditions for synchronization? So the first condition is terminal voltage of the machine to be synchronized must be equal. Well, one alternator is already connected. If you want to connect one more alternator, the terminal voltage of both the alternators should be equal. Second one, frequency of the machine must be same. Second parameter is frequency. Third one, phase sequence, that is RYB. Red, yellow, blue, the sequence of the voltage should be same. So when one alternator is already connected, we are connecting one more alternator, that is called a synchronization. At that time we need to check the both alternator terminal voltage, frequency, phase sequence of voltage must be equal. Then only we can connect, so that there should not be any interruption. For that there are so many methods available. Based on the method we can verify terminal voltage, frequency and phase sequence. Thereby we can connect. So this is the condition for synchronization. Now we'll see the synchronization of single phase alternator. There are two methods available, lamp dark method, lamp bright method. First we'll see the lamp dark method. Now we'll refer the diagram. So this is the infinite bus bar available. Alternator 1 is already connected. We need to connect the alternator 2 by using the synchronization process. By satisfying the condition of synchronization, we have to connect the alternator 2. We know that there are three conditions available. The voltage, frequency, phase sequence should be same for alternator 1 and alternator 2. The voltage can be measured by this voltmeter is connected. V1 will give the voltage of alternator 1, V2 will give the voltage of alternator 2. If the voltage is not equal, by varying the excitation, we can bring both the voltages are equal. By changing the excitation, we can bring. The phase sequence and frequency that can be measured using these switches, the switch S and lamp L1 and L2. The lamp L1 is connected across the switch. L2 also connected across the switch in phase as well as neutral. So by verifying the darkness and brightness of lamp 1 and 2, we can able to identify the various conditions, whether the frequency is equal or frequency of alternator 2 is greater with alternator 1 or lesser, that can be identified. Now we'll see this condition one by one. So voltage can be easily measured with the voltmeter. Frequency and phase sequence will be verified with the darkness and brightness of the lamp L1 and L2. After satisfying condition, we can close the switch in order to synchronize the second alternator into the bus bar. Now we'll see the conditions one by one. So alternator 1 is already connected to the bus bar. Alternator 2 is to be synchronized with alternator 1. That is our aim. First we will see the voltage. The voltage of both the machine is measured by the voltmeter. If the voltage of machine 2 is not equal to machine 1, then the field of alternator 2 is varied to make the two voltages are equal. Right? By using voltmeter, we can measure the alternator 2 voltage is not equal to alternator 1, means we can vary the field excitation. Now we'll go to the frequency and phase sequence. The lamp L1 and L2 are connected in such a way to check the polarity of the polarity and frequency of the machine. We know that L1 L2 is connected across the switches in phase as well as neutral side. If the frequency of both the alternators are same and if the voltages are in phase opposition, the resultant voltage across the switch terminal is 0. So the lamp will not glow. So this is shown by this waveform. So if the frequency of the both alternator is same and voltages are in phase opposition, in that condition the resultant voltage is 0, so the bulb will not glow. Both the voltages are opposing, but the frequency is equal. Frequency is equal, but the voltage is in opposing. So that resultant voltage is 0, lamp will not glow. So that can be verified with this waveform. So this is the voltage V1. The voltage V2 is given by the dotted lines. See, this completely opposing. This is positive cycle, this is negative cycle. It's completely opposing, so the resultant voltage will be 0. Frequency is same. Frequency of alternator 1 and alternator 2 is same. This is the time period. Frequency is same. But the phase is opposing, completely opposing. So the resultant is 0. So in that case, the lamp will not glow. Now I will go to the next condition. If the frequency of both the machines are not equal, then a resultant voltage will appear across the switch terminals, which will be difference between the voltage V1 and V2. So if the frequency is not equal, means the resultant voltage will be appear, that is nothing but difference of voltage V1 and V2. Now the lamp will become alternately bright and dark because of different frequency. The difference in voltage will appear, so it will go with brightness and darkness. So the first condition, the lamp is not glowing. In second condition, frequency is not equal, then the difference in voltage appears, so that we got the dark and bright condition. It can be seen with unequal frequency of two alternator, a bright beam is produced, whose number is equal to the difference in frequency of two machines. So the time interval between dark and brightness is defined by the difference in frequency. So by adjusting the speed of the the frequency are made to equal. For the voltage we are adjusting field excitation. For frequency we are adjusting the speed of the machine, so that we will make two frequencies are equal. So for this we can see the waveform, that is two different frequencies. So this is the waveform with two different frequencies. See, this is the voltage V1. So this is a time period, positive and negative off cycle time period. This dotted line refers the voltage of V2, second alternator. See, the time period is varies, not matching. They start from here and ending here. The time period is more than the voltage of the first alternator. So skip on, the time period is varying. So this is the condition, voltage is almost equal but the frequency is not equal. So the difference between these two will be appear across the switches, so that we are getting bright and darkness. See this, the sum of these two will produce the resultant voltage. So at this point is very maximum. See this, at this point both are almost the same, so we are getting the peak voltage. Thereafter keep on decreases. Right, now we'll see the next condition. So now when the voltages are in phase opposition with equal frequency and voltage, the lamp will grow dark. So at this instant the alternator 2 should be connected to the alternator 1 by closing the switch. So in the first condition, the voltage is equal, the frequency is equal, voltage is in phase opposition, means no resultant voltage will be 0, the lamp will not glow. Frequency is same, voltage is opposing, so completely resultant voltage 0 will not glow. If the frequency is not equal, then we are getting the waveform like this. So it will go bright and dark, alternatively it go glow bright and dark. That refers different frequencies. If the frequency is equal and phase is sequence, voltage, everything is correct, means the lamp will glow darkness, not completely not glowing, it will give the dark glow. So at that instant we can connect the alternator 2 with the alternator 1. So these are all the procedure. First procedure, lamp not glowing means frequency is same but voltage is completely opposing, no voltage, so lamp is not glow. Different frequency means it will go brightness and darkness alternatively. If frequency is equal, voltage is in phase with, means lamp will glow darkness. So at that condition we can synchronize the second alternator with the first alternator. Now we'll go to the second method, lamp bright method. This is lamp dark method. Next one, lamp bright method. So this is a lamp bright method. This is a bus bar, infinite bus bar available. Alternator 1 is already connected. Alternator 2 we need to connect. So this is the switches available. Voltmeter connected, V1 and V2, to measure the voltage of alternator 1 and 2. This lamp L1 and L2 connected in a crossed manner. Earlier case connected across the switch. either in both in phase side as well as neutral side. Here it is connected between phase and neutral. L1 is connected between phase and neutral. L2 also connected between phase and neutral. In a crossed manner it is connected. So first one, voltage we can verify with the voltmeter. If it is not equal, we can vary the excitation of the second alternator. So we can brought the voltage into equal. Then frequency, that can be measured by this lamp condition. Now we'll see that. In this method, the lamps are connected, cross connected. Lamps are cross connected. So when the voltages are equal and in phase opposition, and when the frequency is equal, the lamp will glow bright. So voltage is equal and in phase opposition. When the frequency is equal, then the lamp is glowing brightness. And the result and the alternator is synchronized in the instant when both the lamps are bright. Right? So equal voltage but in opposition means any one lamp will glow. If both the lamps are glowing means that refers voltage is equal, frequency also equal and in phase. At that time we can synchronize the second alternator with the first alternator. So the alternator is synchronized in the instant when both the lamps are bright. If any one is bright means it is phase opposing. So in this video we discuss what is the synchronization or parallel operation of alternator. Then what is the need for that, what is the condition of synchronization, then synchronization of single phase alternator by two methods, lamp dark method, lamp bright method. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.